All right, so I'm going to be starting this question. So, hello everyone. This is probably the first video I'm making in like 10 years right now. Um, so, let me just introduce myself. I'm Pranav. I'm actually a college student at NYU. I'm just making these videos for my reference. And if by chance any of you stumble upon this video, I hope it would be helpful for you. So what I'm going to be doing is I'm just going to be solving some random Leetcode questions that I think are interesting, and I'll be posting the video solution, and I'll be also giving a rundown on how I approach these questions. So yeah, without further ado, let me solve this question. It's called the maze. It's a premium question. So you guys I can give you the general approach to this question. Yeah. So normally, when we're given questions like this, where you have to find the end point or the destination somewhere, the answer is normally a BFS or a DFS. So if you guys don't know what these are, I highly recommend watching some videos on this topic. So DFS is basically where you start from a source and you keep going from that location from all possible endpoints from here. So suppose you're here, so you first go right, then from here you explore all possible endpoints. So here, from here you explore all possible endpoints like that, like this. And BFS is a little different. BFS is once you start here, we first explore all the possible endpoints from here which are equidistant. So first we take this, then we'll take this and this. Then from here we'll take all the possible breadth which is here only, since this is an endpoint. Then from here we'll take all the possible endpoints. So that's what a BFS is, and a BFS is normally done with a queue. All right. So yeah. So let me be solving this question. So what this question says is that we're given a start and a destination. So the start is here and the destination is here. So we're given it as endpoints, so 0, 4 and 4, 4. And what we have to do in this question is, once we are in this start point, we have to reach the destination, and you have to return true if it can reach the destination and false if it cannot. And one important thing in this question is, unlike other DFS questions, is when you're moving in a particular direction, up, down, left, right, it won't stop rolling until it hits the wall. All right. So now from here, suppose you go left, it will keep going left until it hits a wall, which is here. So this is one possible endpoint from here. Then also it will keep going down until it hits here. This is another possible endpoint, and obviously it can't go top and right since we are already in an edge. So the reason why this can reach the endpoint is it can go here, hit this wall. It can keep going down from here, hit this wall. It'll keep going left from here, hit this wall. It'll keep going down from here, hit this wall. Keep going right from here, hit this wall. Keep going down from here, hit this wall. Then it can keep going right from here and hit the endpoint. Alright. So now it should hit the endpoint exactly. It cannot go through the endpoint. So for example, in this case, it can go right, down, left, down, right, and then here it will go through this endpoint. It won't actually hit this endpoint. So this is not a valid endpoint. Only this is a valid true statement. All right. So now what we're going to do is we're going to be using BFS, right? Breadth first search. So this is a little bit different in the sense that we're not storing actually every path that we're visiting. We're only storing the endpoints. So in this case, now we start here. All right. So what we're going to do in the first iteration of the BFS is store all possible left endpoints from here. So that is only this. Then we'll store all possible right endpoints, which is nothing. You can't go right anywhere from here. Then we'll store all possible up endpoints, which is nothing. And then we'll store all possible down endpoints, which is here. So after the first iteration of the queue, we end up with this element here and this element here. All right. Now we're going to be running BFS from both of these points. So from here, when we run BFS, we can keep going left and hit this wall. So you can't go anywhere left. Then we try right. You end up with here, but this is already we're going to keep track of all the visited endpoints. So this is already visited, so no point. Then we'll keep going top, which is nothing, obviously. Then we'll keep going down, which is here. Right. So this is another endpoint. Now remember, we also had this point from here. So from here we can't go anywhere left, we can't go anywhere right, we can't go anywhere down. We can go here top, but this is already visited. Okay. So now both of these are covered. Now in the third iteration we'll cover from here, this element. This is the only element in the queue. So we can't go top anywhere since this is already visited. We can't go down anywhere. We can't go right anywhere since this is also already visited. We can go right actually. So we can go right, this is a new endpoint possible. We can go left from here, and this is another endpoint possible. So now at the fourth iteration of the queue, we have both of these elements, this one here and this one here. So now from here, now first we'll take this one since it's the first one we reach. So from here, we can't go top anywhere since this is already visited. We can't go down anywhere since this is already visited. We can't go right anywhere since this is a wall. We can't go left, but this is already visited. Remember, from here we already visited here. So this is already, this from here we can't go anywhere. So now we have this element in the queue. Similarly, we'll keep going. So from here we can go top, we can't go left anywhere. We can go right, but this is already visited. We can go top, so this is another element. We can go bottom. So at the end of this, we have this element here and this element here in the queue. So like that, we can keep going. So from here, we can go here like that. All right. So I'll give you the guys the general approach on how we're going to do this using queues. So in Python, usually we need to have the queue data structure. So we have a built-in data structure called DQ that we can use for queues. So as you know, queues is first in, first out. So when we have an element, that will be the first element, and what do you call? We can pop from the left and pop from the right in O of 1 complexity. All right. So before we start any question, I'll just give you guys a general approach on how I usually approach BFS questions. So first, we'll keep the length and width of the maze in handy since it will be useful. All right, so yeah, so now what we're going to do is we first have to keep track of all the visited endpoints, right? So for that, we'll keep a set. Sorry, I have a bit of a cold. So all the visited endpoints, all right? So now also we need to declare the queue, the BFS queue, which we'll just declare as a queue data structure, DQ data structure, all right? So now what we need initially is we need to have the first endpoint in the queue, which is the start endpoint. So we'll just do queue dot append start. All right. So we have the 0,4 in the queue. I'll also show you guys the debugger output at the end just to see the workflow of how this code works. All right. And also we need the visited. We need to add it to visited. So visited dot add. So how I usually add is in the form of a tuple. So we can do start of 0 and start of 1. So what we'll be storing is nothing but a tuple. We'll be storing a tuple of start of 0 is 0, 4. So we're going to be storing this in visited, if that makes sense. All right. So from then on, we'll keep storing new elements in this. So now we have a queue with this element and we have this visited. All right. So let's keep doing this while there exists endpoints. So while there are some elements in the queue. So how I normally start queue questions is, so now we'll first find all the endpoints starting from this element in the queue. So first we need to have the size of the queue. So why I like doing this approach, you don't really need this approach for this question, but in other questions we need to have each layer of the BFS, right? So these two come under layer, so this is layer 0 where there's nothing. These two endpoints come under layer 1. Then from here, this endpoint will come under layer 2. Then from here, these two endpoints will come under layer 3. Then from here, these two endpoints would come under layer 4. In this question, you actually don't require the layer number that importantly, but it can be useful in other questions. So I usually follow this approach. So for I in range size, where we're going to be iterating through all the elements within the queue. So what we need first is we need to pop the queue and get the coordinates of the queue. So is equal to queue dot pop left. All right. So in this first iteration, you get 0, 4. So now what I like doing in questions in general, in maze or BFS, DFS questions in general, is to declare a directions array. So you can go in 4 directions. So this is 4 directional. So where you can move up, down, left, right. So first let's take the right. Let's move left. So 0, -1 is basically a moving left. Now let's move right. 0, 1 is we are moving right. So think about it this way, right? So you have 0, 4. If you add 0, -1, where do you go? You go to 0, 3, right? So that is here, this element here. And now if you add 0, 1, where do you go? You go to 0, 5, which is obviously out of the range of this array, but it's over here, right? Similarly, if you have -1 comma 0, where do you go? You go top. And if you have 1 comma 0, where do you go? You go bottom. So think about it this way. So suppose you have an element like the 0 comma 0, where do you end up going with 0 comma -1? You go out of range, right? So yeah, so if you keep just keep these directions in mind. You can use this for any maze question. So if you want to have all possible ways you can go from this direction, you just keep a directions array in mind. All right, it will be more clear when I do this question. So for dx comma dy in directions, all right. So now we have to go through all possible directions. So first, let me just have this as a comment so that you guys will remember. Zero. So we first have left, then we have right, then we have -1 is top, and then 1 comma 0 is bottom. It's easy to know that whenever we in a two directional 2D in a matrix, whenever we go one step, when we decrement j, we are moving here. When we increase I, we are moving down. I basically controls the top down. J usually controls the left right. So in this case also we move in these directions. Just remember these four correspond to the four directions in order. Alright, so for dx comma dy in directions x, so now we have to calculate a new x and a new y. So first let me just keep the element as it is, so we can calculate it from henceforth, right? So we keep the new x and new y as it is, so 0 comma 4. So now let's keep going left till we find an endpoint, so which will be here. So right, so now what we'll do is, so now we have to keep in mind the range, right? So 0 less than equal to new x plus dx. So what this does is basically the new element. So when you add, in the first case you add -1, right? So 0 comma 3. You have to first make sure that it is within bounds of the array. So which is m and n, which is in this case 5 comma 5. You should make sure it is within this range of 0 and 5. It should be lesser than or equal to 0, and it should be lesser than 5. So which is m, and 0 less than or equal to new y plus dy lesser than n. Alright, so what we're doing in this condition is the new x and the new y, we should make sure that it is within the bounds of this. So from here, when we go left, yep, this is in bounds. We go right, oh, this is not in bounds, so it will not execute. So similarly, when we go top, oh, this is not in bound, it won't execute. We go down, oh yeah, this is in bounds, so it will execute. Alright, and most importantly, the maze of new x plus dx and new y plus dy not equal to -1, not equal to 1. So what this means is you should not hit an endpoint, obviously. So you should not hit an endpoint, as in you should not hit a wall. So these are the walls, right, which is marked as 1 within the array. So now while you're moving this, so now what we can do is we can keep incrementing it, we can keep adding, you can keep going in that direction until we hit a wall. So now once you hit a wall, so it does, in this case you'll keep going. So now in the first iteration we are going left, right? So we're going to be keep going left, keep adding dx dy. So we're going to keep adding 0 comma -1 till we hit a wall or we go out of bounds. So now in this case, so now it's 0 comma 4. We first add 0 comma -1, so you 0 comma 3. We go left. Now we try going left again. So 0 comma minus, so now we go to 0 comma 2. 0 comma 2, as you can see, is 1. So this condition will iterate. So maze comma 1 is equal to 1. So you break from the loop. So think about it that way. So similarly, if we were going down, we are here, we go down again. So you have 0 comma 4, then you have 1 comma 4. So since we are adding 1 comma 0, then you have 2 comma 4, then we have 3 comma 4. So as you can see, 3 comma 4 is 1. So then you break out of the loop. So that's how this direction arrays work, and it's very useful, and it is the best possible way for in all DFS BFS questions. So now we have ended up with the new x and the new y. So first you have to check, is this endpoint visited? New x comma new y, is it in visited? Which is the array that we are keeping. So initially only this is the visited endpoint. If it isn't visited, continue. I don't want to go further. What continue basically does, if you guys don't know, is within a loop, whenever a continue is executed, anything beyond the continue will not be executed within that loop. It will go back. So for example, in this case, so now if this element, if this new x, new y is in the visited array, it will go back. It will check for the next direction, right? So yeah. So now if it is not in the visited, so now we have encountered a new endpoint, which is a good thing. So now what we're going to do is we're going to add the new endpoint. Firstly, you have to add the new endpoint to visited. So we add new x, comma new y to visited. Also, what we have to do now is that endpoint, very important, is that endpoint a destination point? So if this goalpost over here, it can be here or here, it can be here or here, right? So you have to check is that an endpoint. If it's not, so now we can check that. If new x, comma new y is equal to destination of 0, comma destination of 1. Yep. So now we have reached an endpoint. Is this endpoint equal to 4, comma 4 or whatever? Is it? Or an easier way to do this, you don't really need this. You can just check it with an array. So new x, comma new y is equal to destination, right? So now is this position the destination? If it is, then we return true. Oh yes, we have reached the endpoint. So what more is to be done? We can just return true. We have reached the endpoint. Now, if it is not, so what you have to do is we have to add it to the queue, remember. So now at the end of this iteration, we have this and this element in the queue. So what we're going to be doing after this is queue dot append new x, comma new y. Very simple. It's not very complicated. So we're going to have 0, 3 and 2, 4 within the queue. So now this is how we're going to have it. So now, yep, so this will be the question, and now at the end of this iteration we can just return false. After the queue is over and you have nothing, you can just return false. So yeah, this should work. The thing is, actually I'm not 100% sure because I'm running this after a long time, so let's just attempt it. Yep, it's running. I'll just show you guys the debugger too, just to make sure, just to give you guys the workflow and how it works. So let's try submitting. And yes, it's submitted. It's 52% accuracy, which is possibly the fastest you can go. So let me just give you guys a general overview by showing you guys the debugging output, and I'll just show you guys how debuggers work as well. So when you click this, you can click endpoints that you want to view in the debugger. So yeah, so we'll view the queue, we'll view each of the BFS from the queue, we'll see each of the directions, and for the first iteration I'll just show you guys each of the directions, how it goes. Then from the next iteration onwards, I'll just show you how it collects the endpoints. All right, it will be cool. So just click start debug. Yep, so we start from here. So we have the length of the maze and all that. Yep, so we just go to the next endpoint. Yeah, so now what we have right now is we have the 4 directions, we have the maze. Now we are starting with 0, 4 in the queue, and we have 0, 4 in the visited array as well. So now let's start. Length of the queue is only 1, so we have to do this in one item right now. So we first get the first element from the queue. We have 0, 4 from the queue. Alright, so now first we'll keep 0, 4, and then we'll keep going left. So now remember, for dx, dy in direction, so dx, dy will be 0, -1 as it shows here. So now we'll keep going left. So now as you can see, while this condition is true, while there is a possible left, we'll keep going left. Alright, so new x, new y 0, 3. So now we'll check again. Can we go to 0, 2? We cannot go to 0, 2. So now we break and we check. 0, 3, is it in visited? Of course not. So we have only 0, 4. So we add 0, 3 to visited. Now is 0, 3 the destination? Obviously not. So we append it to the queue. So now the queue has 0, 3 in it. Remember that. So now we also remember we have to keep going in all 4 directions. So we have covered left. Now we have to cover right. So new x, new y, we keep going right. Oh, so there is no possible right. Right, correct. So from here there is no possible right. So what this thing will do is it won't execute anything in the y. So now new comma new x comma new y means you stay with 0 comma 4. So you can't go anywhere, right? So this will just continue, as you can see. So now what we're going to do, we have covered left, we have covered right. So now we're going to cover top. So obviously you can't go anywhere top from here. From here we can't go anywhere top. So this will be as it is even in the next one. Yep, you can't go anywhere top. So is it continue? You can, however, go bottom. So 1 comma 0 means it will keep going bottom. So new x, new y. So we can keep going bottom. So we keep going bottom. So new x comma new y. So now we are in 1 comma 4. 2 comma 4 is also within the bounds. So we go to 2 comma 4. 3 comma 4. As you can see, 3 comma 4 is equal to 1. So in this case, 3 comma 4 will be equal to 1. So it will go out, right? So yep, so now you're at 2 comma 4. So 2 comma 4 we added to the visited array. It's obviously not the endpoint and we append the queue. So now we've iterated through both possible BFSs of 0 comma 4. So what it will do is now we are out of this range. We have gone in all four directions and we have got all the possible endpoints. As you can see, we have gone full left, we've gone full right, we have gone full top, we have gone full bottom, all possible endpoints we have gotten. So as you can see, the queue now has 0 comma 3 and 2 comma 4, which is this element here 0 comma 3 and 2 comma 4, which is correct. From here we can go here and here, right? So now we are back to the start of the queue. So we have iterated through all possible. We are back to the start of the queue. Now we have to keep going. So length 2. So now you have both of these elements and we keep going from 0 comma 3 and 2 comma 4. So in this case, let me just not show you guys everything. I'll just show you guys when we are reaching a new direction. Yep. So from here, so we start with 0 comma 3. So 0 comma 3, we go left first. Obviously, you can't go anywhere. From 0 comma 3, we keep going left. You won't reach anywhere. Similarly, if you go right, you won't reach anywhere. If you keep going left, yeah. From 0 comma 3, if you keep going left, you won't reach anywhere. If you go right, you'll reach here, but this is already visited. You go top, you won't reach anywhere. You go bottom, yes, you'll reach here. So this is one possible endpoint from 0 comma 3. Similarly, from 2 comma 4, you keep going left, you won't reach anywhere. You keep going right, you won't reach anywhere. You go top, yes, you'll reach here, but this is already visited. Then you keep going bottom, you reach nowhere. So from here, you can't reach anywhere. So let me just show you guys that in practice. So now in the next iteration of the queue, we will pop 0 comma 3, as you can see here. We have to check 2 comma 4 as well. So yep, so we pop 0 comma 3, as you can see. So now in 0 comma 3, now we'll keep going left and we'll see in left you can't go anywhere. So you'll end up in this condition. Yep, so we have gone right, you can't reach anywhere. So we have checked left, we have checked right. So now dx comma 0 is minus 1 comma 0, which is top. Can you go top? You can't. So back, you're at the end of it. 1 comma 0, you can go somewhere. So in this case, dx comma dy is 1 comma 0, which is the fourth iteration, and you do reach a new endpoint, which is 1 comma 3. So we do add it to the queue. So what this shows is at the end of it, now you have 1 comma 3 also in the queue. So what you have done is from this 0 comma 3, we check left, nothing. We check top, nothing. We check right, nothing. We check down, yes, there is an endpoint here, which we have added to the queue here, 1 comma 3. So it's a very simple approach. You can use this for any possible maze questions and it will work. And yeah, so this is the way we do it. Similarly, so if I can just show you the ending. So also from 2 comma 4, we check all four possible directions and you can't reach anywhere. So I'll just show you guys that. So we check DRs, we check all four possible directions and we have no possible endpoint. Yep. So we check all four possible endpoints. We check down, we have nothing. And yeah, so we are done with this. So we have only this element in the queue, 1 comma 3. So from here we can also check all possible endpoints. So just to give you guys one last example. So now we have 1 comma 3 in the queue. So we go from 1 comma 3, we check all possible endpoints, which is first we go left, we have this in the endpoint. Then we keep going right, we'll get this as an endpoint. Top, we'll get this, but this is already visited. And bottom, you can't go anywhere. So the end of this iteration of the queue, you should end up with, this is 1 comma 0, 1 comma 0 and 1 comma 4. That's what you will end up with at the end of this iteration of the queue. So we pop this. See, new x comma new y is 1 comma 0. We have that in the queue, and in the next direction we go right. We end up with 1 comma 4. See, both of that are in the queue. Then we go top and bottom. You can't go anywhere top and bottom. Yep. And now you're in the new iteration of the queue. It's very simple. See, you're out of the queue and you're in the new iteration. So you have 1 comma 0 and 2 1 comma 4. So you have both of this elements here, and from there we'll keep going, hence so on and so forth. So yeah, that is a question. It's a very simple question. It's not very difficult, and you guys can use this approach for a lot of questions. I really like doing it this way, where you initialize a direction array, and then you check all possible directions from here, and then we go for while, we check within that, and then we go further. So it's a really cool approach to doing this question, and I really encourage you guys to do it as well. Even I learned this technique really recently. So earlier what I used to do is I used to try all four possible directions, like in manually, if. So this method is way better, and I would really suggest you guys using it. I'll be uploading some more videos. So yeah, thank you guys so much for watching. Yeah.